मुझे चैट बॉक्स बता दो हाउ मेनी वीडियोस हैव यू वॉच्ड. वी विल स्टार्ट ऑफ विद योर यूनिट 4 टॉपिक नंबर 6 इलेक्ट्रिक एंड मैग्नेटिक फील्ड्स हमने स्टार्ट किया हुआ है. एंड टुडे विल बी स्टार्टिंग ऑफ विद योर 6B. हमने 6A के अंदर वी हैव ऑलरेडी कवर्ड द बेसिक्स ऑफ इलेक्ट्रिक फील्ड्स, हाउ टू ड्रॉ इलेक्ट्रिक फील्ड लाइंस, द प्रॉपर्टीज, द कूलम्स लॉ, हाउ टू फाइंड इलेक्ट्रिक फोर्स इक्वल टू सेंटीमीटर फोर्स, electric force between two charged particle on a charged particle, uniform electric fields, non-uniform radial electric fields as well. Now we will be starting off with a completely new topic that is known as capacitors. Capacitor भी एक component है that you add in a circuit basically. It is also a very important component और ये ऐसा component है that is there in order to store charge. इसका काम क्या होता है? Capacitors basically store charge. For example, what are we going to study over here? हमने देखना है capacitors in series and parallels को. How is it constructed? How is it used in AC circuits? Other than that, what's the role of capacitors? How do they charge and discharge? Very important. क्योंकि capacitors आप समझो एक छोटा सा एक backup type देते हैं as well. What is times constant? How does capacitors relate to voltage, current and charge, and the different logarithmic functions in order to find the times constant as well. So if we start off with the very basics of your capacitors, we are going to first describe how capacitors can be used in a circuit to store charge, and then we are going to use the equation capacitance is equal to Q over V. इसी को अगर हम rearrange करें तो वो क्या बन जाएगी? Q is equal to capacitance into voltage, and then we are going to use different other equations for finding the energy stored on a capacitor as well. If you talk about storing charge, we already saw that an electric field can cause charges to move, and indeed, this is why a current flows through a circuit as well. When an electric field is set up within the conducting material, and this causes the electrons to experience a force and move through wires and components of the circuit as well. अब एक कैपेसिटर काम कैसे करता है? कैपेसिटर हैज़ अ पॉजिटिव प्लेट एंड इट हैज़ अ नेगेटिव प्लेट. ये अपने दरमियान एक चार्ज स्टोर कर लेगा. इट इज गोइंग टू स्टोर अ चार्ज बिटवीन द प्लेट्स ऑफ द कैपेसिटर बिकॉज देयर इज अ गैप इन द सर्किट. And the effect of the electric field can be experienced by charges across this empty space, and in general, conduction electrons are unable to escape their conductor and move across the empty space, and this is why complete conducting path is also needed for a simple circuit to function. We know कि एक circuit तभी काम करता है when the current starts to flow. The direction of current is positive to negative, whereas if you look at the electrons, they travel from negative to the positive terminal. However, charge can also be made to flow in an incomplete circuit as well. This can be demonstrated by connecting two large metal plates. अब आपको कि सर ये तो सर्किट कंप्लीट है ही नहीं क्योंकि गैप आ गई है. हमने ये पढ़ा ना कि जब सर्किट का स्विच क्लोज होगा ओनली देन द करंट एंड चार्ज इज गोइंग टू पास. ओवर हियर द सर्किट इज ओपन फ्रॉम हियर. How is the circuit open? This is a circuit and we have two plates in between. Isn't this an open circuit? Then still, how is the charge going to pass? Because one of the plate is positive, the other is negative, charge is going to jump across from one plate to another. Because there is a gap between them, you have to overcome that gap. And that circuit shown is very familiar to the situation shown by the photo as well. When the power supply is connected, electric field is created in the conducting wire that causes electrons to flow from the negative terminal towards the positive terminal. And since the electrons cannot cross the gap between the plates, they collect on the plate connected to the negative terminal, which becomes negatively charged. And then the electrons in the plate connected to the positive terminal flow towards the positive of the cell. क्योंकि जैसे ही यहाँ पे सर्किट स्टार्ट हुआ सारे इलेक्ट्रॉन्स विल बी gathered over here, right? And when they are all gathered over here, they are all now going to be attracted towards the positive plate. Now what will happen? This results in a positive charge being on the left on the plate, and the attraction between the opposite charges across the gap creates an electric field. अब आप देखो एक सर्किट ओपन था, but still due to the electrons being concentrated on one side of the plate has made that plate negative and the other plate automatically positive because that plate had no electrons. All of the electrons were present on this plate. Now due to that difference in electrons, whereas all because all of the electrons were on this plate and there were no electrons on the other plate, there has been a potential difference created across the gap. And why has a potential difference been created? Because there's an electric field created. हमने पढ़ा हुआ ना that electric field strength is equal to delta V over D. Delta V over T explains you electric field strength. This is how it's created. Circuit was turned on. All of the electrons always move from negative to positive. ये तो आपको पता है ना. So when the electrons started to move, they all gathered on the negative plate. And when they all gathered on a negative plate, this whole plate became negatively charged. And automatically, where there were no electrons, the plate between became positively charged. Which plate? The other plate, where there were no electrons. And now, when one plate becomes positive, the other becomes negative. How is an electric field created? Look at this. You see, this is how an electric field is created. Because one plate is positive, the other is negative. And when electric field is created, we have a potential difference in an open gap circuit. So this is this component symbol to show a capacitor. Capacitor is basically a pair of plates such as this with an insulator between them as well. We call it a capacitor. As we have seen, the charge will collect on a capacitor until the potential difference across the plates equal to that provided by the power supply to which it is connected. It is then fully charged and the capacitor is acting as a store of charge. The amount of charge a capacitor can store per volt applied across it is known as capacitance. कि एक how much amount of charge can a capacitor store, and capacitance is measured in farads. This capacitance also depends on the size of the plates as well. The greater the size of the plates, greater the separation, greater will be the capacity to store charge and greater will be the capacitance as well. Capacity से निकला ना capacitance. Capacitance comes from capacity to store charge between the plates and it also depends कि उन दोनों plates के दरम्यान insulator कौन सा use हो रहा है. So the very first formula is capacitance is equal to charge divided by potential difference. For example, what is the capacitance of a capacitor which can store 18 microcoulombs of charge when the potential difference is 6 volts? So you can simply divide 18 microcoulombs divided by 6 and you'll get what? 3 microfarads as your capacitance. How much charge will be stored on this capacitor if the voltage is now 20? तो आपकी जो भी capacitance ऊपर आई थी which was 3 microfarad multiplied by the new potential difference and you will get your charge which is 0.06 coulomb. Same is the case that we say that what is a capacitor? Capacitor is basically two plates between which charge is stored. And good capacitor वही होगा जो that can store maximum amount of charge. A charge capacitor का मतलब क्या है? Charge capacitor का मतलब है that it has the maximum potential difference, maximum potential energy, and when the capacitor is discharged, all of that energy can be transferred into other forms. For example, during load shedding, your TV also has a capacitor. The biggest capacitor is in your fridge. ये ये कैपेसिटर्स होते हैं क्यों प्रेजेंट, सोचें ज़रा. और आपने याद होगा वो जो हमारे पंखों के डिमर होते हैं, कभी आपने देखा कि जब भी वो लाइट आती जाती है बहुत ज़्यादा लोड शेडिंग की वजह से. यू कैन टेल मी इन द चैट बॉक्स एज वेल, या तो मैं ही सिर्फ पेंड हूँ, लेकिन हमारे यहाँ तो बहुत मसला होता है. लाइट आती जाती है जो एकदम से एक सर्ज ऑफ वोल्टेज आता है, ये सबसे पहले आपके कैपेसिटर्स ख़राब करता है. और आपने सुना होगा कैपेसिटर चेंज हो रहा है पंखे का, डिमर्स का, स्विच बोर्ड्स का, फ्रिज का, टीवी का. क्यों? बिकॉज इन कैपेसिटर्स का काम क्या होता है? व्हेन इलेक्ट्रिसिटी इज देयर, ये चार्ज हो जाते हैं और जैसी लाइट जाती है उसी वक्त टीवी नेवर शट्स डाउन. टीवी टेक्स अ फ्यू मिली सेकेंड्स बिफोर शटिंग डाउन. क्यों? क्योंकि जैसी लाइट जाती है कैपेसिटर थोड़ा सा मिनी बैकअप प्रोवाइड करता है. एक जो फ्रिज भी होता है, फ्रिज भी एकदम से बंद नहीं होता. सोचो अगर एकदम से बंद हो जाए जैसी लाइट गई है फिर तो फट जाएगा. वो फायदा नहीं है. फ्रिज कैन उसको कोई हार्म भी पहुंच सकता है, ख़राब भी हो सकती है. मशीन है ना, मशीन तो ख़राब हो सकती है. बट फ्रिज में भी कैपेसिटर होता है क्योंकि वो बहुत देर से चार्ज पड़ा है, वो तो तैयार बैठा होकर लाइट जाए. कैपेसिटर का काम है, उसका काम है कि जैसी लाइट जाएगी मैंने उनको 1 सेकंड का बैकअप देना है. आधे सेकंड का भी बैकअप दे दे तो बहुत है. और वो उस दौरान डिस्चार्ज हो जाता है. फिर जब दोबारा से लाइट आएगी तो कैपेसिटर विल गेट चार्ज अगेन, अपने अंदर स्टोर कर लेगा कि मुझे किसी वक्त दोबारा से डिस्चार्ज होना पड़ सकता है. इज दिस क्लियर? समझ आ गया? सो बेसिकली आवर डेफिनेशन ऑफ वोल्टेज टेल्स अस व्हाट. आपको याद है दैट वोल्टेज इज वर्क डन पर कूलम चार्ज, मतलब कि इट इज बेसिकली द एनर्जी per coulomb charge. So if we make energy or work done the subject, the formula will become what? Energy is equal to voltage multiplied by charge, right? So E is equal to half QV can also be used to find the energy in a capacitor. और the second formula is कि in place of Q अगर आप CV लिख दो तो फॉर्मूला क्या बन जाएगा? 1/2. Q की जगह CV लिख दें मल्टीप्लाइड बाई V, तो वो क्या बन जाता है? Either you can use this formula, E is equal to half QV, to find the electrical energy stored in a capacitor, or this is the second formula that you can use to find the energy stored in the capacitor as well. Each time we add a little extra charge, this has to be done by increasing the voltage and pushing the charge on as well, which takes some energy. We are doing work. By finding the area of each nearly rectangular trip, we also find V into Q, which is the amount of extra energy needed. ये देखिए, these are the three formulas. Formula number one to find the energy, formula number two, and formula number three. These are the three formulas that you can use in order to find the energy stored in a capacitor. What is the energy stored on a charged 100 microfarad capacitor which has 3 millicoulombs of charge? तो you can easily, अब आपको Q और कैपेसिटेंस दी हुई है और Q दिया हुआ है, ऐसा कौन सा फॉर्मूला है एनर्जी इन अ कैपेसिटर के जिसमें Q भी और C भी है? ये तो नहीं है, ये तो नहीं है। हाँ, दिस फॉर्मूला कैन बी यूज बिकॉज इट हैज Q एज वेल एंड C एज वेल. So 3 millicoulomb square divided by 100 microfarads give you the energy stored in a capacitor. So capacitor is an electrical circuit component that stores charge, and it can also be used as an energy store. Capacitance is also a measure of capability of a capacitor, which is the amount of charge stored per unit voltage across the capacitor measured in farads as well. तो जो सेकंड कॉन्सेप्ट है, अब इसको चार्ज कैसे करना है एंड हाउ आर वी गोइंग टू डिस्चार्ज दीज कैपेसिटर्स इज वेरी 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 इंपॉर्टेंट कॉन्सेप्ट. यू हैव सीन इन फिगर ए वेयर इज द कैपेसिटर प्रेजेंट. दिस इज द कैपेसिटर, राइट. इस कैपेसिटर की वैल्यू क्या है? इट इज 100 माइक्रोफैरड कैपेसिटर. We have a bulb over here as well. We have a 6-volt battery. We have a switch as well over here. And when this switch is closed, इस switch close का मतलब क्या है? That the current is flowing. And if the current is flowing opposite direction में आपके पास electrons are also flowing, which means that this side of the capacitor plate is going to become negative and that side of the plate will automatically become positive. So the charge has started to being stored. This is the point where the capacitor is being charged. In figure A, the capacitor is fully charged and it will be at 6 volts when Q is equal to CV. We know that it will be storing 0.6 millicoulombs of a charge. We looked at previously as well that how the electrons in the circuit are influenced by the electric field caused by the supply voltage and their own mutual repulsion. If the two-way switch in figure A is moved to position B, electrons on the capacitor will be able to move to the positive side of it by discharging via the lamp. As it has a 100 ohm resistance, their progress will be slowed by the lamp, but they will still discharge. And the lamp will light on as long as some current flows through it. Even अगर आप इस सर्किट को क्लोज भी कर देते हो, क्या होगा? एकदम से लैम्प बंद हो जाएगा? नहीं. It will light on for, let's say, a few seconds or maybe a few milliseconds. Why? Because there was some charge already stored in this capacitor that is being used to keep the lamp on after the switch was opened. So after a few milliseconds, when all of the energy and the charge from the capacitor has been used, capacitor has been fully discharged, लैंप कुछ मिलीसेकंड्स के बाद बंद हो जाएगा. अब जब सर्किट दोबारा आएगा, जब लाइट दोबारा आएगी, कैपेसिटर फिर बाद में फिर से चार्ज हो जाएगा. At first, what will happen? The rush of electrons as the capacitor discharges, it is as high as it can be. The current starts at maximum and we can calculate this current by using the V is equal to IR as well, और वही आपको बता देगा. ठीक है. Sometime later, what will happen that the flow of electrons is so small that the current is down to a trickle and the lamp will be so dim that it may be look like it is almost off. अब जब लैंप डिम होना शुरू हो जाएगा थोड़ी देर बाद, क्योंकि स्विच आपने देखो, स्विच जैसे ही आपने ओपन किया, नो मोर करंट इज फ्लोइंग टू द लैंप. लैंप अब किसके सहारे चल रहे? लैंप इज ओनली डिपेंडेंट ऑन द कैपेसिटर. आहिस्ता आहिस्ता द ब्राइटनेस ऑफ दिस लैंप विल स्टार्ट टू बिकम डिमर. The brightness of the lamp will start to decrease. This means that this capacitor is slowly being what? This capacitor is slowly being discharged. And when this capacitor is slowly being discharged, lamp dim se dim hota jayega, meaning that there are no more electrons moving from one plate to another. The current will then almost become zero. And if we put this story together over time, the discharging current, potential difference across the capacitor, and the charge will same follow the patterns over here. With time क्या हो रहा है? you can see current is also decreasing. With time, voltage is also decreasing. With time, the charge in the capacitors is also decreasing through the light bulb. So this is how these capacitors basically work over here. All right, times constant is a different topic. Let's look at that in the next lecture as well.